Last week we learned about capacity, and this week we will learn more about volume. So just to recap, capacity is how much a container can hold completely, and volume is the amount of 3D space that an object occupies or takes up. So 3D is a solid that is three-dimensional, and they take up space, and that can be measured and that's called volume. And capacity is the complete amount that a container can hold. All 3D objects or solids that take up space have volume. So we're going to look at, for example, a rock which has volume too. And because a rock occupies space, if you put this rock into a cup of water, you will notice that the level of water rises. And this is what we're going to discover in this lesson. The water is displaced. It no longer keeps its place. It is displaced because the rock begins to occupy space in the cup and forces the water to move out of its way. So that's why the water rises, because the rock has volume and it's taking up space, and the water needs to move out of its way. So today, we are learning to measure and compare volume. Miss Krystle has a container with water in it. When she places an object into the water, she notices that the water level changes. These are some of the objects that she's going to use in her container to measure the volume. I wonder how she can use what she noticed to compare the volume of some objects. Should be she. The first success criteria is to fill half a container with water and mark the water level. Then we're going to place an object into the container and mark the new level of water. Next, we will record the volume of the object. We can draw this or take a photo. And after that, we will measure and compare the volumes of other objects. As you can see, she's got 3 objects to measure the volume of. The challenge is to order the objects from the least to the greatest volume and draw and label a picture of your work. You can see in these 2 containers another example where the rock or the pebble was placed into the second tube and the water level rises. When you finish the task, you need to come back to this check understanding to see if you can answer the question. This picture shows the water level in the bucket. If I drop a stone in the bucket, will the water level rise or lower? I'd like you to do this task first before you answer the question, and then come back to this question to see whether it's actually what happens. Just remember that objects displace their own volume when totally submerged in water. So to summarize, we are learning to compare and order the volumes of 2 or more objects by marking the change in water level when each object is put under the water. Alrighty, boys and girls, today we are going to be doing another lesson on volume and capacity. Just as a VIP, I hope you've checked this VIP slide before. That capacity is how much a container can completely hold, and volume is the amount of 3D space that an object takes up. The space that is taken up. So let's have a look at today's task. We've had a look at it already on the slide before, but the first step says, first half fill a container with water and mark the water level. So I've filled my container up to here. It's not exactly half, so I'll need to add a little bit more water. A little bit more. So it's about, it's probably too much actually. Pour a little bit out. So it's about halfway full. I've put it on my bench and I'm going to make a mark over here. And I'm just I'm gonna write W because that's my water level. Now, The next step says, then place an object into the container and mark the new level. So any object at all, I've got a lemon. I'm going to carefully place the lemon and the water has risen. So I'm gonna put a mark there and I'm gonna write L for lemon. And I'm gonna bring it closer so that you can see the lemon. I've written an L because the water level has risen up to show the lemon. I'm going to carefully take that lemon out. Try and shake off any water. Put it down. Then the next step says, next, record the volume of the object. So I can draw this or I can take a photo. I can take a photo of it or I can draw it. Then the next step says, after measure and compare the volumes of other objects. So I have got a magnet that I'm going to place carefully into, and it's just a little bit higher. So I need to get this closer to me. Wait for the water to settle. And it's just a little bit over the water level. And I'm going to write M for magnet. Can you see? In the middle of the lemon and the water level is the magnet level. Now I need to do one, I'm going to do one more. Carefully shake off that water. And I'm going to measure one more, the volume of one more. I love minions. So I'm going to measure my minion globe. Now, I have to be very careful to place it. Oh my goodness, a little bit of water came out the top, but if you can see, it's up to here. Hold on, it's wet, so I need to just, alrighty. Now I'm going to carefully take that out. Oh, I don't know if I can actually, but I'm going to show you. At the very top, there's my minion coming up. It's popping. He's coming out. He's over the top. That's the globe, but the water level has risen up here. The next step says to order the objects from the least to the greatest volume. So, and then we're going to draw and label a picture of our work. So, if I were to order this, I know that the least would be my magnet, the least volume, that takes up the least amount of space, then my lemon, and then my minion snow globe. So today, we have measured and compared the volume of my three objects. The minion globe has the most volume and the magnet has the least volume. On the left, you can see the marks that were made for the minion globe, the lemon and the magnet, and the last mark at the bottom was the water level where the water started. And on the right, you can see how I've ordered them from least to most and compared them below, saying the magnet has the least volume and the minion globe had the most volume. So once you have finished that task and you've answered this check understanding question now, after you've had some time to think about it, this is another check understanding question. Which type of food would be most accurate for finding the volume of the container? So have a look at the food that's inside the container and think about which food in this container would be the most accurate to count the volume inside this container. It's a tricky question to think about. Today, We are learning to create different objects with the same volume. Different objects with the same volume. Jenny made this model. All of the blocks were the same size. I wonder what other models might have the same volume. The first step in this success criteria is to first make a connected model of your own with the exact same sized objects. So you need something that is exactly the same size. So you may not have cubes, like Jenny. So you may look for other objects of the same size, and I will show you some different examples in a minute. Then record the volume by counting the objects. So for example, the volume of Jenny's object that she has on the left is 8 cubes because there are 8 cubes. Next, you're going to create other models using the same number of objects and explain whether they have the same volume. And the challenge is to work out how many different models can be made with half the volume of your model. So thinking about if you had half the amount, so if Jenny had half the amount of her model, half of 8 would be 4. If she only had 4 cubes, how many different objects and models could she make with those 4 cubes? So these are some examples of multiple same-size objects that you might have lying at home. Bobby pins, safety pins, pegs, or you might have blocks or cubes at home. If you have cubes, these are some different examples of cubes that you might be able to use for this task. Now, I didn't have these types of cubes, so I created my own cubes, but you don't need cubes. You can use other objects like these. Once you finish the task, come back to this check understanding question to count the volume of this object. How many cube units are used to count the volume of this object? Alrighty, so we've gone through this in the previous slide, and the first step says to first make a connected model of your own with the exact same sized objects. You may not have cubes. You may not have cubes like Jenny. I will show you what to do if you don't have cubes like Jenny. I don't have 8 cubes like Jenny, but I've got 6 cubes that I made. You don't need to make these, but if you have cubes, this is what you would do. Make a connected model. It doesn't have to be like Jenny's, but I want to make sure that these are as much as possible touching each other, and I'm going to pretend that they're super glued together because I don't have Lego pieces. I don't have blocks that connect to each other. You might, but I don't. So I'm going to pretend that I have connected these together with my magic super glue, and I only have 6 cubes. So 1, 2, 3, 4, 5, 6. So the volume of this new object that I've created with my cubes, the new volume is 6 cubes. This object takes up the space of 6 cubes. That's the volume of this object. Now, I have recorded that volume by counting the objects. The next step says to create other models using the same number of objects and to explain whether they have the same volume. So I need to keep my 6 cubes, but I need to create different objects using these 6 cubes. So that means I can change them around a bit, but still have the same amount of cubes. So imagining again that they're super glued together. If I had changed the formation to create a new object, which is this now, does the volume remain the same? Have a think about it. What if I then create a new object again? You have to remember that we're pretending that these are glued together or they're interlocking like Lego pieces or like Unifix cubes. Okay, this is my new object. Would the volume remain the same? Have a think. Now, the challenge is to work out how many different models can be made with half the volume of your model. So if I have 6 cubes, what's the volume? What's half of 6? Yep, it's 3. So if I had 3 cubes, I have to work out how many different ways I could arrange these. How many different models could I make? There's 1, 2, and I could go and do some more. Now, if you don't have cubes, that's totally fine. You can use anything that you have exactly the same sized objects of. So more than 4 objects. So I have a lot of bobby pins, like you know, and I've gone ahead and created a model by connecting them together. And then I can say the volume of this new object that I've created, could be like, you know, some new fidget toy, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The volume of this new object I created is 10 bobby pins. So that's how much space it takes up. 10 bobby pins is the volume of this object. And then I could create other models using the same amount. So I could take them apart from this creation, and I could change the formation as long as they're touching. It's a bit hard to see. As long as they're touching, pretending that I'm super gluing them together, I'm going to make a formation, and I have to keep the 10 objects that I started with. So I am imagining that I'm super gluing these together because I can't connect them because I'm not at school and I don't have my Unifix cubes, but I'm pretending that these will connect, and I'm creating a new model using my 10 objects. I've got 2 more to add. And they all have to be touching. Does the volume remain the same when I've changed my model? I've created a new model using my 10 bobby pins. Have a think about it. Now, I could also use other things like, safety pins. They're connected. I could also use pegs. So I've created a model, using 1, 2, 3, 4, 5 pegs. Now, if I wanted to do this next step, because I could say the volume of this is 5 pegs, but if I then create another model using the same amount of pegs, does the volume remain the same? What about if I changed it even more? Would the volume remain the same with my new model? Have a think about that. So the learning intention was that we were learning to create different objects that have the same volume. And again, no matter how many objects you start with, the challenge is to work out how many different models you could make with half the volume. So this final lesson has a VIP to begin about informal uniform units. These units are of the same size as each other. For example, the blocks that you can see in the images below are all the same as each other in size. You can see that the bobby pins are all the same in size, and the pegs are all the same size as each other. So uniform units are the same units, and informal just means we're measuring with different types of objects. So we are learning to record and order volume using uniform units. We're going to record the volume and we're going to order the volume, counting it using informal uniform units. The volume is the amount of space, 3D space, that an object occupies, takes up. Volume can be counted, but you need to use the same unit. Miss Krystle had 3 different models and wanted to order them from most to least volume. I wonder how many units might she use and how should she organize and count the units. So you can see that the first step is to make 3 different objects using identical uniform units. You can use cubes if you have them, but if you don't have cubes, then that's okay. You can see some examples in a minute. Then you're going to record the volume of your objects. And then next, you're going to compare your volumes and write some sentences to explain this comparison. After that, you will order the volume of your objects. The challenge is to follow the instructions at this link to make an infinity cube and explain why the volume remains the same no matter the formations. It's a pretty tricky thing to do, so it's not compulsory, but if you want a bit of a challenge, you're welcome to try it out. That's how I made my individual cubes, but I didn't make the infinity cube. So here are the cubes that I made. You do not need to waste your time making cubes because this whole lesson is not a lesson on 3D space, it's a lesson on volume. So I just have them here to show you my 3 objects that I created. I created one object with a volume of 3 cubes, a volume of 3 cubes. This object has the least volume. Then this object in the middle has a volume of 4 cubes and it takes up more space than the 3 cubes. The words in bold are the key words here that I'm using to compare and to compare these objects. And this last object has the greatest volume of 6 cubes and takes up the most space. And you can see that all of these are uniform units. Now, if you don't have cubes, you might have pegs at home. I've created 3 objects using my pegs. You can see the first object on the left has a volume of 3 pegs, and it has the least volume. And the second object's volume is 5 pegs and takes up more space than the 3 pegs. And the last object on the right has the greatest volume of 8 pegs and takes up the most space. You could also create objects using bobby pins. The first object on the left of my bobby pins has a volume of 2 bobby pins and has the least volume. The second object's volume is 4 bobby pins, and the last object has the greatest volume of 8 bobby pins, and it takes up the most space. So you can see there my examples. This last step, we are learning to record and order volume using uniform units. We've gone through this task in the previous part. Now the first step is to make 3 different objects using identical uniform units. It says use cubes if you can, but if you don't have cubes, that's totally fine. I'm going to show you an option of what you can do if you don't have cubes. Now, if you check to the VIP side and you listen to that instruction, you would know that identical uniform units are units that are the same. So I need to make 3 different objects using this same unit. If I had cubes, I could have, this could be my first object. No, maybe I'll just do one because I don't have many cubes. This can be my second object. Pretending, imagining that they're glued together, remember? And that's my third object. So I have 1, 2, 3 objects using identical uniform units. The volume of this is 1 cube, 2 cubes, and 3 cubes. And then I need to compare my volumes and write some sentences, which I'll show you soon, that I could write. This cube has the least amount of volume, which has got 2 cubes less than the object that has the most volume. The object that has the most volume is 3 cubes. And then I can say this object has 2 cubes, which is 1 less than this object. Remembering, we're imagining that they're super glued together. Now we're using the words more than, less than, most, and least. And I've compared them, and I have already ordered these from least to most, but you might not have had them in that order. You might have had them like this to begin with. So then I would need to order them from least to most. So then I could say, okay, so that's my one that has least, that has the most, and then that one has, that's the middle. Now, if I didn't have cubes, oh, also just a side note that to create these and learn how to make these and to create an infinity cube, there is a challenge here. It's quite tricky, so you don't have to do it, but it's a challenge if you wish. And you can look at that if you wish to get to that. But if you don't have cubes, you could also use what I spoke about yesterday. You could use pegs. So I've created 3 objects here using pegs because I have a lot of pegs. So you can see that I've got 3 objects using pegs, which is the first step. And then I need to record the volume of these objects. So I would say 1, 2, 3, 4, 5. This object has a volume of 5 pegs. This object has a volume of 3 pegs. And this volume has this object has a volume of 2, 4, 6, 8. 8 pegs. So that's got a volume of 8 pegs, 3 pegs, and 5 pegs. And then I have to order these from either most to least or least to most. So I'm going to do least to most. So 3, 5, 8. And then I can write a sentence as well to say that this object has the most volume. And I'd write that in a sentence. And I might say that that one has 5, and that one had 2, 4, 6, 8. So this one has the volume of this object is 3 pegs more than the volume of this object. So that's that task. You can't do the challenge if you with this for pegs. That's you can follow that link if you choose to. I could use my safety pins and I could create 3 different objects using those connected, or I could make 3 different objects, different sized objects using my bobby pins or whatever you have at home. If you walk around your home and if you try to look for things, uniform units that you have lots of, that you can create different objects to measure the volume and order them, then you can go ahead and do that. So that's the task for today.